Here's question number, I don't know, 3, I believe, on 7-6. It says tangent theta is negative 10, sine theta is less than 0. So what does that tell us? Tangent is negative. That means we're either in the fourth or the second quadrant. And I made that look like a J. How about a T? And then it says sine is less than 0. That has to be the fourth quadrant. Now, later on, we're going to have to figure out what quadrant our half angles are in, so we know whether those are positive or negative. So we know we're in the fourth quadrant. Sine is negative. So we'll write these here. Sine theta. And cosine theta is going to be positive because we're in the fourth quadrant. Well, what are they? Tangent is negative 10. So let's draw our triangle. We really don't have to worry about the signs of anything because we know the signs of the functions. So it says tangent, it says negative 10, but we're just going to write 10 over 1. Here's theta. So the hypotenuse is equal to the square root of 1 squared of the 2 sides squared plus 10 squared equals the square root of 101. And again, we don't really, well, for the double angles, we have to know the signs of these functions. We don't care what it looks like in the triangle because, again, we know we're in the fourth quadrant. So sine is going to be negative. It's negative 10 over square root of 101. And cosine going to be adjacent 1 over square root of 101. And again, we're in the fourth quadrant, so cosine is positive, sine is negative. Now we can do our formula. So this is A. Sine 2 theta equals, it's 2 sine theta. Wait a minute. For some reason, my pen is not writing well on the whiteboard all of a sudden. 2 sine theta cosine theta equals, all right, sine theta, so it's 2 times negative 10 over square root 101 times 1 over square root 101. And that equals 2 times negative 10 times 1 is negative 20. Square root of 101 times square root of 101 is 101. So the sine of 2 pi is negative 20 over 101. And those sine, when we're doing the double angles, the sine, as long as we get these right, what our original sine and cosine are, everything comes out right. It's only when we do the half angles that we have to know which quadrant we're in for the half angle in order to do the positive square root or negative square root. All right, here's B. Cosine of 2 theta. I've forgotten what the formula is, so I will look here. Cosine 2 theta. Well, we can use any one of these. I'll use one, and then you can use the other ones to prove to yourself that they will all work. 1 minus 2 sine squared. That's the one we'll use. So 1 minus 2 sine squared theta equals 1 minus 2. Now sine theta is negative 10 over 101, so sine squared is 100. Negative 10 times negative 10 is 100. Square root 101 squared is 101. So 1 minus 200 over 101. I need more room. I'll get it like this. Watch this. You thought I was out of room. Okay. 1 is 101 over 101 minus 200 over 101 equals minus 99 over 101. And I will check that one on our double angle calculator, we want B, which is the cosine of 2 theta. Sometimes the signs on this calculator are wrong for the half angle, so you need to know whether it's positive or negative. Tangent negative 10, I've got the right. Tangent is negative 10. I've got the right quadrant, and calculate it, and I get negative 99 over 101. So that's good. All right, C. Now this is where that half angle calculator isn't going, it's going to show the right number but the wrong sign. So we know that we're in quadrant 4. How do we know what the sign, S-I-G-N, of this thing should be? Well, let's check it out. And I'm going to do it right. Yeah. Okay. So let's just do it for this one, and then I'll write the other ones down so we have them all. If the original angle is in quadrant 4, we know that 270, or 3 pi over 2, is less than theta, is less than 2 pi or 360, whatever you want to write. So now we just divide all of those by 2. And 135 is less than theta over 2 is less than 180. So 135, 180, that's in the second quadrant. And so if the original angle is in the fourth quadrant, the half angle is in the second quadrant. So that's what we'll be using for this one. Let's look at all the other quadrants just so we have them. If the original angle is in the first quadrant, that means 0 is less than theta is less than 90. And again, you can write these in radians if you want. So we divide all of them by 2. 0 divided by 2 is 0, is less than theta over 2, is less than 45. Still in the first quadrant. So if our original angle is in the first quadrant, we are still in the first quadrant. If our original angle is in the second quadrant, we know that 90 is less than theta, is less than 180. Again, you can do them in radians if you want. It's just to find out what quadrant they're in. And then you can memorize this list. 45 is less than theta over 2 is less than 90. So if the original angle is in quadrant 3, the half angle is in quadrant 1. And then again, did I get them all? Quadrant 1, quadrant 3. Oh, I forgot quadrant 2. Look at that. Quadrant. Oh, that is quadrant. Hold on. Did I say quadrant 3? I said quadrant 3, and then I wrote 90 is less than 180. That should have been quadrant 2. So if they're in quadrant 2, 90 is less than 180, and then half angle would be in quadrant 1. And then quadrant 3 is going to be 180 less than theta less than 270. Divide them all by 2. I need more room. Now I can't find my magnifier. And again, you can memorize this list or just rework it every time, which it'll take some time though. We divide by 2, divide by 2, divide by 2. 90 is less than theta over 2 is less than 135. So that is in quadrant 2. So quadrant 3 and quadrant 4 go back to quadrant 2. Quadrant 1 and quadrant 2, if the original angles are there, go back to quadrant 1 for the half angles. I'm just making sure 90 over 2 is 45, 180 over 2 is 90. Yes, so if the original angle is quadrant 2. Well, again, so we know that our original angle is quadrant 4, so our half angles are in quadrant 2. So in quadrant 2, let me zoom in a little bit. In quadrant 2, the half angles are in quadrant 2, so in quadrant 2, sine is positive, so this is going to be the positive square root, and for the other one, cosine is going to be negative. But anyway, let's look at sine of theta over 2. And let's look for our half angle formulas. If you don't know them, I'm about to scroll down to them through all of this work. And again, we are positive 1 minus cosine theta over 2. 1 minus cosine theta over 2. All right, what does that give us? Cosine theta is 1 over square root 101. So this is equal to square root of 1 minus 1 over square root 101 over 2. And who knows, you can write it just like that, or you can try to get rid of that square root of 2 in the bottom by rationalizing, but then you'll have to rationalize the 101. So that answer will work. All right, D. Now remember, D is the cosine theta over 2, and we have determined that since it starts in the first quadrant, if you don't have this list memorized, let me go back to this list if I can find where my scroller is. If we're in the fourth quadrant, the half angle is in the second quadrant. So in the second quadrant, cosine is negative. So this is going to be negative square root. And then what's the formula for cosine? 1 plus 1 over square root 101 over 2. So this is going to be negative. And that's our answer to all of them. So we just learned, based on where the original angle is, how do we find what quadrant the half angle is? And then we did some examples of finding the double angles and half angles. Very good.